Now, with an explicitly defined sequence, the term is based on n. And that's how we're going to find out whether it's explicit or recursive. So in an explicit sequence, an is equal to n plus 16 is an example. Now what I want you to notice here is that n is the number in line. The place of it. This is not a subscript. So with this, if I say find the fourth term, that means n is equal to 4, and therefore A4 is just equal to 4 plus 16, or 20. And if I want to find the 8th term, then that just means A sub 8 is equal to 8 plus 16, or 24. So explicitly defined, you can tell that it's explicitly defined because n is in the formula and it is not a subscript. So I want to talk about this one particularly because this one has a special piece in it that's really important. If you ever see -1 to the n power, this will give you a sequence that alternates signs. The one will be positive, the next term will be negative, positive, negative, positive, negative. And that's due to the fact that when n is even, you'll get a positive number, and whenever n is odd, you get a negative number. So if I want to find the third term, then the third term would equal -1 to the third power all over 2 times 3 plus 1, or -1 in the numerator. In the denominator, this gives me 6 plus 1, or 7. Now, if I'm looking for the fourth term, that -1 is to the 4th power, which is going to make it even. In the denominator, it's 2 times 4 plus 1. So that gives me a +1 in the numerator. And down here, that's 8 plus 1, which gives me a 9. So this will be one of those examples of that sequence that alternates from positive to negative. All right, so let's go ahead and compare some of these. So whenever you have a recursive equation, you use n minus 1. And when we have explicit, we use n. Recursive means you always use the previous term. For explicit, you just need the term you're looking for. So if we go through and we want to write a formula for these, let's look at the set of odd numbers. 1, 3, 5, 7, and continues. This is an infinite sequence. We don't know what the end is. So for a recursive formula, you always start with the first term. The first term here is 1. And then the next term, you always have to have the previous term, and that n minus 1 is the previous term. That's always what that means. What is the term before? And then what is this doing? It's adding 2. So that's how you would do the recursive formula. Now, for the explicit formula, we have to do some value here with n. I can't use anything else. So the trick with this is to deal with an even number. 2 times n, and let's look at that. If n was equal to 1, that would give me 2 times 1, which is 2. I don't want that, but if I go through and subtract 1 from it, that will work. Then that would give me 2 times 1, and I would go ahead and subtract 1, which would be 1. Now, let's test it again for n is equal to 2. Well, when n is equal to 2, it would be 2 times 2 minus 1, which is 4 minus 1, which is 3, which that matches up with my first term. A1 is equal to 1, and A2 is equal to 3. So let's go ahead and look at another set. Only this time we're going to go ahead and use the even numbers. So let's say our sequence now is 2, 4, 6, 8, and on and on. The recursive formula, A, N, and remember with the recursive, the first thing is always going to be the previous term. In this one, I just add 2, because that's what you're doing each single time. And for the explicit formula, AN is just equal to 2 times n. And the idea of using an even and an odd is one I definitely wanted to show you. It happens quite often. And there's another sequence that happens quite often. This is called a power sequence. And it's important to recognize how to write these. And we're going to still use 2, 4, but now it changes and it's going to become 8, 16, 32. So it's important to recognize what's going on here. This is the same thing as saying 2 to the first, 2 squared, 2 to the third, 2 to the fourth, and so on. Now, you can probably guess this is going to be 2 to the n power here, and that's correct. And that gives us the explicit formula, because you could find any term inside here knowing that a to the n was just equal to 2 to the nth power. Now, the recursive formula, a little bit different, but again, we always have to have that a to the n minus 1 here. Same idea, but only this time you just multiply it times 2.